This is the video for section 11.2, day 1, Properties of Tangents. Please follow along with your video worksheet. The first section has all of the terms, definitions, and diagrams that I will be using, and the second section has all of the example problems that I will be showing you. Please fill in your worksheet as you watch the video. Let's begin. Our first statement says, if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So I start here with line L, and they tell me that line L is tangent to our circle C. So since it's tangent to that circle C, it just barely touches the outside of circle C at point B, the point of tangency. So since I know that my line is tangent to the circle, it tells me that this radius CB drawn to that point of tangency and line L are perpendicular. Now this is going to be used later on in problems that look like this. We're going to be using the Pythagorean theorem to solve for different sides of this right triangle. Our second statement here is just the converse of the first statement that I just showed you. It says, if a line is perpendicular to a radius of a circle at its endpoint on the circle, then the line is tangent to the circle. So in this case, we know that our line, L, and our radius, segment CB, we know already that they're perpendicular. So since we know that they're perpendicular, then we know that line L is a tangent to our circle. Our next statement says, if two segments from the same point are tangent to a circle, then they are congruent. So what this says is if segment RS and segment TS are both tangent to the circle from the same point S, then they have to be congruent. So we will mark those congruent. Here's our first example problem. It says line FE is tangent to circle D at E. Now because the line is tangent to the circle, we know that that line is perpendicular to the radius drawn to the point of tangency. So I draw that little right angle symbol in there. Next thing I'm going to be finding is DF. Now DF is the hypotenuse of our right triangle. So that's going to be like the C side in the a squared plus b squared equals c squared. So I set up my algebra problem here. 8 squared plus 15 squared, because those are the two legs of my right triangle, equals c squared. 8 squared is 64 plus 15 squared is 225 equals c squared. 64 plus 225 is 289 equals c squared. Taking square root of both sides, c equals 17. Now that 17 is the hypotenuse of our right triangle, which is the one I have shaded green, which is segment DF. So I'm going to write DF equals 17. Next we're looking for DG. Now DG is going to be a radius of that circle. It's going to have the same length as every other radius to the circle. So this one right here, which is 8, and the one that I just found, DG, are going to be congruent. So DG equals 8. Now to find GF, which is that little piece of the hypotenuse that's outside the circle, I'm going to be taking the hypotenuse, which we found to be 17, and I'm going to subtract off 8, which is the radius, and that's going to give me the piece that's outside, which is 9. So GF is 9. Moving on to part B, we also have line FE is tangent to circle D at E, And what that does is it allows us to make a 90-degree angle at that point of tangency. we also know that one of our radii, DE, is 6.2, so every other radius of that circle is also going to be the same thing, or 6.2. So DG is 6.2. Now that, along with the 4.7 that's outside the circle, if we add those two things up, I'm going to be getting 10.9. Now 10.9 there is the hypotenuse of my right triangle. So I'm going to be looking for EF. Now before that I just found DF, which is 10.9, so I'm going to put that on my answer blank. And then to find EF, EF right here is one of the legs of my right triangle. So it's either the A or the B side. So I'm just going to go ahead and say that's the B side. So I have 6.2 plus squared plus B squared equals 10.9 squared. Simplifying, I get 6.2 squared is 38.44 plus B squared equals 10.9 squared is 118.81. Subtracting 38.44 from both sides, I get B squared is 80.37. I then take a square root of both sides and I get B is approximately 9.0. And this number I'm going to be rounding to the nearest tenth. So B, which is right here, is EF, is approximately equal to 9.0. Moving on to question 2, it says you are standing 25 feet from the edge of a circular swimming pool. The distance to a point of tangency is 45 feet. What is the radius of the pool? Alright, so you are standing right here. And you're standing 25 feet from the edge of the pool. So we want to measure the shortest distance to the pool, which is 25 feet. And it also says the distance to a point of tangency is going to be 45 feet. So this piece right here is going to be 45 feet. And it's going to the point of tangency. And we know a radius drawn to that point of tangency and the tangent are going to be perpendicular. And we're asked for the radius of the pool. So I have two radii here. I'm going to call one R there and the other R right there. And before I set up my Pythagorean theorem, I'm going to add these two sides to get the whole hypotenuse, which is 25 plus R. I then go ahead and start to set up my A squared plus B squared equals C squared for the Pythagorean theorem. I get R squared plus 45 squared equals parentheses 25 plus R quantity squared. So simplifying, I get R squared plus 45 squared is going to be 2025 equals, now this 25 plus R squared we have to be really careful with. I'm going to go off to the side here and say 25 plus R squared is going to be 25 plus R times 25 plus R. And then I distribute, I get 25 times 25, which is going to be 625, plus 25 times R is 25R, plus another 25 times R, and the last terms is plus R squared. Collecting my like terms here, I get R squared plus 50R plus 625. And I'm going to put that right there. Now, solving this equation, I subtract R squared from both sides. The R squareds do cancel out. I get 2025 equals 50R plus 625. Next, I'm going to subtract 625 from both sides. That gives me 1,400 equals 50R. divide by 50, and r equals 28. So that tells me the radius of my pool is 28 feet. Moving on to question 3a, it says the two segments shown are tangent to the circle. Find the value of x. Now if these two segments are both tangent to my circle, they are going to be congruent to each other. So the algebra problem I set up says 3x plus 20 equals 6x minus 7. Subtracting 3x from both sides, I get 20 equals 3x minus 7. Adding 7 to both sides, I get 27 equals 3x. Divide both sides by 3, and I get x equals 9. So if x equals 9, the two segments are going to be congruent to each other. Now using the same procedure, we also know that the x squared minus 5x tangent is going to be congruent to the negative x plus 12 tangent. So I'm going to mark those congruent to each other, and then I go ahead and set up my algebra problem. I get x squared minus 5x equals negative x plus 12. Then I'm going to bring everything over on one side of the equal sign. So I'm going to add x to both sides. That gives me x squared minus 4x equals 12. Then I subtract 12 from both sides. That gives me x squared minus 4x minus 12 equals 0. Now this is a quadratic equation, and the way to solve this quadratic equation is by factoring. So I'm going to set up my two sets of parentheses, and the factors of x squared are just x and x, and the factors of negative 12 I can deal with either 1 and 12, 2 and 6, or 3 and 4. And I want the ones that add up to the negative 4x in the middle. So I'm going to be using the 6 and the 2. So when I put in a negative 6 here and a positive 2 here, negative 6x plus 2x does give me the negative 4 that I'm looking for right there. So that's factored correctly. Then I set each of the two parentheses equal to 0. X minus 6 equals 0. That gives me x equals 6. Or the second one, x plus 2 equals 0. Subtract 2 from both sides, and x equals negative 2. So either x being 6 or x being negative 2 does make those two tangents congruent to each other. That concludes the video on section 11.2 day 1, properties of tangents. Thanks for watching.